Hello everyone, in this section we continue with the content of the previous section to introduce the basic knowledge of storage in cloud computing. Let's take a look at virtualized and non-virtualized storage. The virtualization and non-virtualization storage are actually a narrow concept. Storage virtualization is a very broad concept. Any action that logically divides physical storage device can be classified as storage virtualization. For example, the RAID we mentioned earlier that converts multiple physical hard disks into a logical physical volume is storage virtualization. This includes formatting the hard drive, partitioning it, and then creating a folder on it, which is also storage virtualization. So, let's take a look at storage virtualization on the cloud. What it actually refers to, and what its conversion path is. First of all, the bottom layer is the physical hardware, and then we have to do a RAID or a copy mechanism. RAID refers to centralized storage, while distributed storage is used as a copy mechanism. It then generated a physical volume and logically divided the physical volume. Why do we want to divide it logically? Because the physical volume can be used directly by the host of the up layer. Logic volume are generated after logical partitioning. On the other hand, we can format this physical volume directly and let it produce NFS with a file system. After logical division, this logical volume can be directly mounted to the host. In this case, we mount it to cluster and then format it. After formatting, a file system is generated, and file system refers to the virtualized file system. Once the file system is mounted and then the host is mounted to the host, the storage that the host sees is no longer a physical hard disk. It sees a shared dictionary which completes the conversion path of the entire virtualized storage. So, let's take a look at what a non-virtualized storage conversion path is. The bottom layer is also a physical hard disk. It is also necessary to do a RAID and a copy mechanism to generate a physical volume. Here, we do not need to format it, but directly logically divide to generate logic volumes. The logic volume does not need to be formatted and can be directly mounted to the clusters to generate a virtual hard disk. This is called non-virtualized storage. Let's compare virtualized and non-virtualized storage in cloud computing. Virtualized computing clusters use everything that has a file system. On the other hand, non-virtualized storage computing clusters is a storage without a file system. Its file system is handed over to the upper operating system, which is the operating system of the virtual machine. In the virtualized and non-virtualized conversion path, we have mentioned RAID and logical partitioning many times. A RAID is actually a very large physical volume made up of multiple hard disks. The advantage of RAID is that it's efficient and safe. After completing this physical volume, we have no way to directly map this physical volume to the host. At this time, we need to logically divide this physical volume. Let's take a look at how the LUM is created. First of all, the bottom layer has lots of physical hard disks. Then we RAID it to form a large physical volume. The physical volume is then split into multiple small logical units. Each of them is a LUM. As we said earlier, the biggest difference between virtualized and non-virtualized storage is that virtualized storage has a file system, while non-virtualized storage does not. The file system in this case refers to the file system of the virtualized cluster. For example, Huawei's virtualization product. Its file system is called VRMS. VMware's is called VMFS. and different cloud computing companies name it differently. But the file system is not only a virtualized cluster file system. Generally, it includes non-storage file system, such as the NFS file system we mentioned earlier, the file system of our most common operating system. For example, when the Windows operating system is formatted, it will let you choose whether it is FAT32 or NTFS, which are both its file systems. In Linux system, ext3, ext4, and so on are all its file systems. Why do we want these file systems? Is it possible to duplicate the file system? Generally speaking, operations such as copy, paste, create that we usually do on operating systems like Windows and Linux rely on the file system in it. How does this happen? There are two floppy disks. You will leave a mark on the floppy disk every time you write data. But when you want to modify this file, this token cannot be moved freely on the disk. Then, how do we do the movements and modifications that we usually perform on the operating system? Look at the process of mapping files to disk. First, we look at the LVM logic area. As mentioned above, once the physical volume formed and the RAID is complete, it cannot be directly mapped to the above computing cluster or the host. It must be logically divided. What does this logical division do? That is, we see that the physical area of the disk mentioned below forms an LVM logical area through LVM mapping. Then we look at the above. We will format it with the hard disk. What does formatting do? It is the process of forming a file system block. The file system block and the LVM logical area correspond to form a logical mapping table. Each time I create a file, this file is stored on the file system, and then the logical area of the LVM is formed through the file system block. The logical area records which sector of the sector the files can be placed on. This completes the process of mapping the entire file to disk. While we move to the file, we do not make any modification to the physical area of the disk. What we modify is only which file system block the file is mapped to. When the file system is mapped, in short, the file system is very useful. In the operating system, there is a file system. We can freely search for a file modification. Then, with the file system in virtualization, we can implement some advanced features. The underlying hardware is logically partitioned and also mounted to the computer cluster. At this point, our virtual machine can be used. When a virtual machine is used, it also forms a virtual disk. So, what exactly a virtual disk? Let's briefly introduce it. The virtual machine disk is no different from the physical disk in terms of the user. In computer disk management, I can partition this hard disk, format it, expand a certain partition, and so on. From the perspective of the administrator, the virtual machine disk is a file. Corresponding to the virtual machine disk in the virtual machine configuration file is a few lines of commands. There are several common virtual machine disk formats. RAM is generally accepted by all cloud computing companies. VMware uses the VMDK. Both Microsoft Hyper-V and Huawei's Vision Compute use VHD. There are two formats dedicated to QEMU at KVM virtualization platforms, QED and VDI. Finally, there is an Oracle VDI format. When you see a file in the future, when the suffix name or the view attribute is in the above format, it is a disk file of the virtual machine. After finishing this basic storage knowledge in this general-purpose cloud computing, let's take a look at the characteristics of Huawei's virtualization product storage. First, let's take a look at the storage architecture of Huawei's virtualization products. At the bottom is the storage hardware. Some are efficient storage blocks. Some are SAM storage or NAS storage. All of them are called storage resources. This needs to be manually added on the external interface of the VRM. For efficient storage, you need to enter the IP address of the management address of the efficient storage. For SAM storage and NAS storage, their management address are needed. Going up is the LAN that we logically divided or the shared directory of the NAS. All of them are called storage devices. After adding the storage resources, we can scan out the LAN or shared directory. Continuously going up, it is data storage. There are three types of data storage: raw device mapping, virtualized storage, and non-virtualized storage. Virtualized storage, non-virtualized storage, we have already talked about before. Raw storage mapping is to directly mount a LAN to a virtual machine. This is called raw device mapping. Manually add storage resources and then add storage devices before adding data stores. The virtual machine can put data. This is not enough because the needs of customers are diverse. Next, let's take a look at what features Huawei's virtual disk has based on customer needs. First of all, it can be divided into three categories. The first is the type. The second is the configuration mode. The third is the disk mode. First, look at the types. The types can be divided into normal and shared. What does normal mean? That is, my virtual machine disk is used for this virtual machine. The sharing is that several virtual machines can read and write to one disk. The second is configuration mode. The configuration mode is also divided into two categories. One is normal and the other is streamlined. The normal mode provides all the space that customer needs one of. The meaning of streamlining is to promise to give the customer a certain volume of space, but only providing space that customers actually need. The normal mode reads and writes faster. Streamlined mode saves space. The third one is talk about disk mode. There are three disk modes: dependent, independent and persistent, and independent and non-persistent. The biggest difference between the dependent and independent is whether it will be affected by snapshots. You only need to remember that under subordinates, this disk will be included under both snapshots and import snapshots. Independent mode. Snapshots and import snapshots do not have any effect on this disk. Independent and persistent data will be brushed, rarely written to the hard disk. Under the independent and non-persistent data is not brushed. Data will be deleted once the virtual machine restarts. These are the characteristics of Huawei virtual disks. With these three features, we can configure different modes according to customer needs. For example, if a customer needs to be shared by multiple people, we will configure it as a shared type. If the data is only temporarily saved, then we configured non-persistent. If the customer wants to read and write quickly, we will make it normal. At this point, the basis of our storage in cloud computing is just finished. To summarize, this chapter involves knowledge from the bottom-level physical disk to the top-level virtual disk. In general, the process of writing data is described. There's two questions. One about the type of physical disk. The other is a true and false question. Remember our first 7 goals? How much do you remember now? Welcome everyone to our official website to leave comments. The content of this lecture is over. Thank you.